Now I'd like to talk about interfaces for a few moments. An interface is nothing more than a promise by you as a programmer to provide specific functionality within some particular program, and it's virtually always done through methods. In other words, the interface approach to something guarantees that a certain specific piece of code has a method in it that behaves in a very, very specified way. They only provide signatures. In other words, an interface does not provide any implementation. And if you'll remember an earlier conversation where we tried to make a distinction between define and declare, interfaces are nothing more than method declarations. There's no implementation code associated with an interface in and of itself, which is a good thing because then that leaves the implementation details to the programmer who wants to implement the interface. They can write that particular method in any way that they wish as long as they conform to the signature that's been specified in the interface. The syntax for an interface is very simple. By definition, all interfaces are public because it provides a way to talk between classes. Therefore, and since there's no properties associated with it, a public interface has to be used. The keyword interface has to be the second expression in an interface syntax declaration. And then the last part of the interface is the interface name itself. And here's an example of a very simple interface. Public interface I get payment. The reason for the word or the letter I is by convention and habit over time, most programmers prefix any interface name with a capital I. Now what we're saying is that if you're going to use the I get payment interface, you must provide a method called get payment, and you must supply one argument to it as an integer, and it's supposed to represent a member number. So maybe we're talking about a gym membership or membership to an investment club or whatever, but whatever that purpose for that get payment is, it has to follow that specific signature. So get payment is going to have to take an integer argument to make itself work, and it must return a decimal value. So evidently we're going to return some kind of money value from this particular interface. If you wish to use this interface, you are the one that's responsible for writing the payment method. Now this leads to a flexibility. For example, suppose that you are running a club of some kind. Let's say it's an investment club. And it starts off simple, and the only method of payment that you actually have is cash. So you would write a get payment method using the I get payment interface, and you would write whatever it takes for you to record collecting money from a specific member, and you would return that value as a decimal value to whatever wants to call this specific interface. Now, suppose that you later then decide that you're going to start taking credit card payments. You can now write a get payment that would also have a credit card interface. So you can go through this interface from the user interface. Think of the user interface as what the person running the program is seeing. Go through the interface, and on the back end then have two different types of get payments that work through the interface to provide for either credit card or cash payments. In other words, interfaces give you a convenient way to add features to software without breaking the old implementation of the software. For example, here we have a class called credit. And you'll notice at the top I say public class credit, colon, I get payment. In other words, the syntax for using an interface is virtually the same as it would be if you were doing an inheritance approach. Remember, you've seen a lot of Windows forms that used the form name, colon, and then the word form, referring back to all of the functionality that a Windows form has. Well, this is sort of the same thing, only in this case we're using an interface rather than some form of inheritance through a library. Now, here we have an implementation of class credit using the iGetPayment interface. The first method that you see there, public decimal get payment int member num, that's the one that says we're going to abide by the rules. We're promising to provide the functionality that is required by the iGetPayment interface. Now you'll notice in the GetPayment interface, I now have a method that's called readCreditCardFile based on the member's number. And we're going to return perhaps a dollar amount there. That then gets returned as a decimal value from GetPayment, and we've fulfilled the interface. The interesting thing is, though, inside of the GetPayment code, we can add all the complexity that we want to read credit card files. We can have it absorb cash from some kind of a payment. We can also add later on perhaps a way to process checks. There's an unlimited way then for us to work through this GetPayment interface to handle a variety of different ways of getting paid on the back end. Another way of visualizing all of this is think of it as a client-server paradigm, where the client is the user interface that whoever's running the program sees, and the server is the different types of payments that this particular program might accept. It starts off simple, only taking cash. It then adds credit cards. Maybe later it adds check cashing facilities. And then even later after that, it maybe accepts payments by mail. In the middle, between the client and the server, is the interface. That's the one gateway then into all of the different payment methods that you are free to use. And you can write that get payment then to be as complex as you want to address whatever payment methods you wish to implement. The advantage is that by going through an interface, the client or the front-end user interface doesn't talk directly to the mechanics of the program. Instead, it goes through an interface. And by going through that interface, you move the complexity out of the user interface and back into the back end of the class where that type of complexity belongs. Anytime that you want then to add another type of payment, you would just add another new class for that particular payment type. So the server now becomes more than one class. You go from class cash to class credit card to class check to class bank by mail. All of those can go through that same simple interface. And you just add a little bit of logic to the get payment method, and it all ties together. And like I said, the advantage is that you can add new features to a particular program without breaking the old code because they all are going to go through the same interface handler. We've talked briefly about interfaces, but what we want to do now is to give a little more concrete demonstration of what they're all about. An interface, as we said, is a way of communicating between two pieces of software, if you will. And what we have here is not a bad way to think about it is in a client-server approach to things, where form main becomes the client and the classes become the server. And what we want to do is between the two, client-server is a classic two-tier architecture. And now we have n-tier architectures where between the client and the server, we have different classes that we can stick in there that might arbitrate rules, as, for example, who has access to the database, who has access to the database but can update records, and so forth. In a way, an interface serves as that intermediary between the user interface and the classes that we want to talk to. In this particular case, what I've modeled, it's a very simple model to keep the complexity down, is I'm saying that we have payments that come in from a member. Perhaps we're talking about a church membership, or maybe we're talking about a fraternal order of some kind, or even a golf course membership. And when this club started, perhaps the only thing that they were capable of taking would be payments from a member could only be made in cash. Well, the tendency is simple code would be then just to write some hard code, put it in, and accept the cash, put it in the proper accounts, and credit it, the payment to a member. With an interface, what we want to do is we want to define specifically how those payments are made. And at the top here, we have a public interface. I get payments is the standard nomenclature that's used anytime that you define an interface. And almost always by convention, this is not a syntax rule, but by convention, it almost always starts with a capital I. That sort of flags it in the person who's reading the code that I'm looking at an interface declaration. Now, again, this is a declaration, not a definition. And the reason that it's a declaration is because there's no code actually defined here. All we have are signatures for the two, in this case, the two methods that the interface expects to find with any class that says that they're going to implement this interface. What that means is anytime that I want to create a class that uses this interface, all I have to do is specify I'm going to use this interface, but I must provide the code and an implementation for these two methods that are part of the interface. So now let's go and look. We have over here, you can see that we have three classes: payment by cash, payment by check, and payment by credit card. Cash, I haven't implemented it in terms of really hard code, but let's take a look at what that looks like. First of all, when you define the class, you use the colon just like you did in inheritance. Only in this case, you're going to pass in an interface name instead of a base class name. So that tells me that this class is going to use an iGetPayments interface. By definition, then, this class must have definitions for getPayment and getMember. If I comment out, for example, let's comment out getMember. I now have a class that's implementing the iGetPayment interface, but I don't have a getMember method. So if I run this, I should get an error, and it says cache does not implement interface member iGetPayments getMember, and that's the one that we just commented out. So the compiler knows that you have to have some form of implementation of those two particular methods. Now, here, what all I've done in the getPayments is call a dummy method inside of here called howmuch. Now, you might be asking yourself, why make this private? The reason that I make that private is this is a helper method. Remember when we talked about the different types, we talked about property methods and constructors and general methods and helper methods. And we said that helper methods are those methods that you don't want to expose as part of the public interface. They're just for your use only. So what would really go in here would be how much this person is going to pay, and maybe there's some rules about they have to pay $125 a month. If it's less than that, maybe something else happens. The important thing is form main doesn't have to know these details. You can change anything that's going on in the cash class, and form main doesn't have to know about it because we're going through an interface to collect the money. And the advantage of that is then the two are totally independent of one another. In other words, in terms of our discussion before, we don't have any coupling between class cash and the form main in terms of the mechanics of how those things work. We are totally independent. All we have to do is somehow fulfill what these two functions or methods are supposed to return. The same for getMember as to who paid. That would be the membership number. That might require going out and reading a database and matching something up, or maybe it's just because this person is paying in cash, it's just typing in the member number when he hands over the dollar bills. Whatever that implementation of who paid becomes, we don't have to worry about it back in form main. It's not our responsibility. Then as time goes on, the club gets more sophisticated, and now it has check processing. Well, we go and look at the check class, and again, We're just saying that it implements the iGetPayments interface, and we know then that it has to have a getPayment and a getMember method in there. We don't care how it's implemented in this class either. So the real code, these are actually just mirror images of what you saw in the other one, but the mechanics of how someone pays with a check doesn't matter to us. It can be whatever is required to be, but it's not our responsibility. Somebody else has to worry about it. So once again, we've minimized the coupling that takes place between the two elements of the program. And if you think of it as in a client-server architecture where form main is the client and the classes are the server, the interface stands in between the two and serves as the link between the functionality of the cash, credit, and check classes. Then, of course, the last one, which was the credit card payment, is exactly the same. Once again, all we have to have are those two methods, and let the details of how those credit cards are processed be the domain of whoever is going to handle the processing of the credit cards. In real life, interfaces not only isolate classes from the user interface to some degree, but it also allows you to work in programming teams a little more effectively. As it turns out, quite often someone develops expertise or a speciality in terms of maybe a database programming, or maybe they understand how to interface with credit card machines or something like that. That way you can parcel this out. You don't care how they write it as long as they implement these two methods. Okay, now going back to main, we have these three existing right now, and we've been able to expand it over time, but we don't break it in terms of backwards compatibility. So if we started out with cash only, and then we added checks, we can still take cash. There's nothing that we've done in release 2 of the software, so to speak, that breaks the earlier releases. Then in release 3, we add credit card payment. The other ones are still going to work because everything goes through an interface. And if there's some change that's required in any of the earlier versions, we hide those in the helper methods. Because they're not part of the user interface, no one outside of the class has any knowledge of the changes that are made, so there's no way for it to interfect the way the program looks on the screen. Interfaces then have the advantage of decoupling the classes from the user interface. It has another advantage in that it makes it easier to add functionality over time. For example, if we want to now add a fourth category called class online payments, someone would have to write the class online payments using the iGetPayments interface, and we don't care how they write it as long as they can return back to me the amount that they paid and who paid it. That's all I'm interested in. So when I run this program, and I've kind of just dummied it, I have, okay, start, and I just show the member and how much they paid, and another one for cash, another one for credit, and then I just repeat it. Obviously, it's not going to change because the data is hardwired in the classes. But the idea is, and the benefit of using interfaces is that you decouple the classes from the user interface, and you will have an easier time of maintaining compatibility between releases of software if you program for the interface. Too often when you develop software, you program for the class, and you become, whether you realize it or not, you become more intimately tied into the methods of the class. You'll notice these classes function perfectly with just using the interface. And if you design a class correctly, remember, each class is supposed to represent an object, one object. And we don't want a Swiss Army knife class, just like we don't want Swiss Army knife methods. Well, it's the same thing here. An interface can be very, very simple, one or two methods, and yet it provides for future extensibility as the needs arise. So keep interfaces in mind. If you can, it's nice to program against an interface. Program to the interface and try to forget what's behind the interface. Let the other people worry about how the interface gets used in the class itself. You just have to worry about working through the interface. If you do that, I think you're going to find your complexity of your software goes down and the extensibility of your software goes up.